We spend a lot of time talking about becoming a multiplanetary species. We map out colonies on Mars, plan outposts on icy moons, and treat the rest of the solar system like an uncharted frontier, just waiting for us to arrive and set up camp. But the physics of these planets tell a much darker story. Outside the thin, comfortable bubble of Earth's atmosphere, our solar neighborhood is an aggressively hostile environment. Human biology is incredibly fragile, and these worlds are naturally equipped to destroy it. To see exactly how fragile we are, let's take a theoretical walk. We are going to teleport onto the surface of every other planet in our solar system, completely unprotected, to find out exactly what physical mechanisms would cause our vital signs to flatline. The solar system operates as a series of distinct planetary execution chambers, each one meticulously optimized to dismantle human biology through a different physical mechanism. In the inner solar system, the primary threat is proximity. Everything here operates under a constant, overwhelming barrage of thermal energy from the sun. Stepping onto Mercury exposes you to the raw, unfiltered force of that star. Because Mercury has almost zero atmosphere to trap, distribute, or deflect heat, its surface temperatures are violently unstable. If you land on the sunlit side, the 430 degrees Celsius heat melts the flesh off your bones. If you step into the shadows, the temperature plummets instantly to minus 180 degrees, flash freezing the water in your cells in seconds. Venus, by comparison, looks almost inviting. It shares a similar size and rocky composition to Earth, wrapped in thick, opaque outer clouds that make it look completely serene from a distance. Those clouds are composed of pure sulfuric acid that will immediately dissolve your lung tissue. Beneath them, a runaway greenhouse effect traps the sun's energy, baking the surface at 450 degrees Celsius. Simultaneously, the atmospheric pressure pushing down on you is 92 times heavier than Earth's. You are dissolved, cooked, and crushed into a pulp. In this inner zone, the presence of too much atmosphere, or the complete lack of it, guarantees rapid thermal and pressurized destruction. Which brings us to Mars. We point our cameras at this rocky, desert-like valley and see a landscape that closely mimics the dry regions of Earth. It's why Mars is our primary target for colonization. On a summer day at the equator, the temperature can reach a comfortable 20 degrees Celsius. But the moment you take off your helmet, your lungs try to process an atmosphere that is incredibly thin and made entirely of carbon dioxide. You asphyxiate in minutes. If you somehow held your breath, the secondary threats finish the job. Nightfall brings a sudden plunge to minus 130 degrees. Unfiltered solar radiation bombards your DNA, and violent global weather events whip up suffocating dust storms that engulf the entire planet. The visual familiarity of Mars is a trap. Without heavy-duty sealed habitats, stepping onto the red dirt guarantees rapid suffocation and deep freezing. Past the asteroid belt, the physical composition of the solar system completely flips. We leave solid rock behind and enter the domain of the outer planets, immense spheres composed almost entirely of hostile gas. Arriving at Jupiter or Saturn presents an immediate mechanical problem. There is absolutely nothing to stand on. Stepping out of a spacecraft here means you simply fall endlessly into the atmosphere. Saturn's rings give it a peaceful, majestic appearance, but descending into its upper cloud layers exposes you to storms whipping at 1,800 kilometers per hour. Your body is violently torn apart by turbulence before you can even register the drop. This vertical depth chart illustrates what happens if you bypass the surface winds and continue falling. The sheer mass of gas above you skyrockets the pressure, forcing the atmosphere to shift from gas into liquid and eventually into a dense metallic state. On the frozen giants, Uranus and Neptune, you combine this terrifying pressure with minus 220-degree deep freezes. The atmospheric weight here is so intense that it crushes the surrounding methane gas, compacting carbon molecules into actual diamonds that rain toward the planet's core. The outer planets offer no ground, only a crushing abyss. The sheer weight of these atmospheres ensures that human biology is compressed out of existence thousands of miles before ever reaching the center. Our theoretical walk confirms exactly what the astrophysics predicted. Every other world orbiting our sun is defined by a fatal extreme: an absolute vacuum, an ocean of toxic acid, or infinite crushing pressure. Our most advanced spacesuits and heavy-duty rockets aren't conquering these environments. They are simply providing a fragile, temporary barrier. They are desperate attempts to carry a tiny, pressurized bubble of our home world's baseline conditions with us into the dark. The breathable oxygen, the precise atmospheric weight, and the stable temperatures we experience every day act as an incredibly rare, intricate safety net, perfectly tuned to protect our specific biology. Before we look to the stars for a backup home, we must accept that Earth remains our only functional sanctuary in a profoundly hostile universe.